77th edition. Today we'll be presenting Internals and Power of Hashicorp Vault by Dinesh Balasubramaniam, a thought worker. Before starting, if you have any questions during the presentations, please put it in a question and answer panel. So we'll be answering at the end of the presentation. So yeah, without any further ado, over to you, Dinesh.
Thank you. Let me share my screen. Hello everyone. Hope you all are able to see my screen. So today we are going to talk about Vault, the power of Vault, and internally what are the architectural decisions Vault has made in order to achieve the features that it is providing. So myself, Dinesh Balasubramaniam, been with Thoughtworks for past 5 years, been a DevOps engineer for past 2.5 years. So I have a lot of experience on handling a lot of configurations, credentials for a lot of microservices, and handling a lot of databases, credentials for the database to be given to the application, and how we are able to consume those secrets. So, and I have worked a little bit about Vault and seen the power and feature of Vault. So I thought I can share my experience with Vault with you all. Yeah. Before starting, let me give you some problem statement. Let's all think what we will generally do in this kind of situation. So now let's say we have a Postgres instance running on the VM, and suddenly there is an issue in the Postgres instance. Maybe all the queries are taking so much time, things like that. Now, in order to debug, you have to SSH into the machine, and you have to, after SSH, you have to, using some pSQL client, you have to get into the Postgres so that you can run some queries about what are the current activities, how many current connections are happening. Based on this, you can come to some conclusion why Postgres is behaving differently due to some condition. Now, you may not have a permission. Reason being, it is a production. Even if you have a permission, if others are asking permission, will you give it? If you are giving it, how much are you sure that they will use it correctly? So these are the things you have to consider. So yeah, this is the one problem statement. So this is very important because it is a production database. We cannot give access to anybody. So it is very important that who is having access, what and all they can do with the access, how long they can access this Postgres database. Because when somebody leaves the company, are we sure that we have taken back the SSH access, taken back the Postgres credentials? So these are the things we have to keep in mind when we are encountering this kind of situation. Similarly, let's say this is another scenario. Let's say one of your VM is compromised. Maybe you are running one web service that is publicly exposed without any authentication authorization, which means anybody can come in, can fetch this, use this web service. Or let's say the port 22 is opened without any authentication, which means anybody can SSH into this VM, which means any VM that are connected to this VM is also compromised, because using this machine, they can SSH because all are in the same network. Similarly, if, let's say this VM is connecting to some Jenkins or some key value store in order to fetch the credentials to configure the application. Let's say it want to talk to database, which means it will fetch the configurations from the key value store and talk to the database. Or it will have the credentials as the environment variable so that it can talk to the database. So similarly, these credentials and environment, these credentials are spread across all these places, by which attacker can misuse these credentials. So what are the steps we will do if we know this kind of situation happens? Now we need to stop and protect whatever compromised data during this crisis. Now we have to, if you see some of these things, right? We have to stop the VM or fix the VM from compromise. Maybe we have to close the port 22 for external users. Only internals can access. Some rules we have to write, some firewall rules, and update all this sensitive information in the key value store, because this is leaked. Let's say we have some SMPT server password, which means anybody who are having these credentials can send email on behalf of us. Let's say we have some DB passwords. They can connect to the database and see important data in the database. Let's say they have the Play Store credentials, which means they can upload some fake applications in the name of our company or our identity. So these are very, very sensitive information which cannot be compromised. If it is compromised, we need to update all these configurations to the new configurations so that all the old credentials are waste. Now, in order to achieve that, we need to find the list of applications which are using this keys, which are all applications using this DB password, which are all using the. So if you see SMPT server, multiple microservices can be configured to send mail, which means we have to go on each and every microservice and has to put the new configuration, and we have to restart the microservice in order to fetch this. Now, yeah, we have to fetch this. So these are the steps we have to do. If you see, this is very tedious process, because in order to update all the configuration is tedious, and find which and all application using which configuration is also another tedious process. Now, so some of the another questions in terms of same line, how frequently are we rotating the passwords and the secrets and the certificates? Are we really rotating it? And how easy it is to rotate? Let's say it is very, very difficult. If we seen previously, we have to do a lot of steps in order to rotate the passwords that are compromised. Similarly, if you want to rotate, say 6 months once, how easy it is to rotate? If you want to follow the same steps as this, we will never do it because it is very tedious. So if it is not easy, we will tend to not do it. So if an employee leaves a company or a project, are we sure that we have removed all his or her permissions, SSH permission, database permissions, Grafana dashboard, all the things? Have we removed it? Is it possible to know who is currently having access to the production instance? Let's say if somebody log in into the production in order to debug, is there a way in order to see who and all is currently accessing the production instance? So that let's say if some attacker is viewing, we can using those logs, we can see whether somebody is misusing it or not. Do we have that in place currently for all your production system? How quickly or easily are we able to give permission to the new team member with less privilege because they are new team member? How easily we are able to give permission? Let's say somebody want to debug it. Are we able to give only read-only permission because they are going to debug? We just want to give because they are going to see the activities, number of connections, or all only read-only queries. So we can give only read-only user and give the credentials to them, and maybe we can give with a small TTL. So are we doing it currently? So these are the problem statements and the questions that we have to think about when we are managing lot of credentials, secrets for all our microservices, applications, all the things. So in order to solve this problem only, Vault came into picture. So Vault is a centralized secret management store. It can be used to store the secrets, the static secrets, and also Vault can also be used to create dynamic secrets. We will talk about dynamic secrets in detail. And also Vault can be used for data encryption. Let's say we are sending a data from an application to the database, which means anybody who during this transmission, anybody can see this data and do it. So we can use TLS, and also we can do data encryption. So before sending this data from the application, we can encrypt it using the Vault. And while writing data into the database, we can decrypt and write it. So in this way, we can have data encryption using Vault. So we have lot of uses for a Vault. Let's say as a user, as a human being, I will go and create some credentials, username, password, secrets in the Vault. As an application, as a process, my microservice will fetch those credentials and use it. In this case itself, there are two types of identity. One is a user, which is me, and another is a process, which is my Spring Boot application, which wants to connect to the database using the credentials that are stored in the Vault. So we can use identity-based management. As a user, human, I can create, write, update. But as a process, my Spring Boot application, I can give only access to read because it is only going to read the credentials and use it. It should not modify or update any of my credentials. So we can have identity-based access. Who can do what? Audit logging. So as we talked previously, do we know who are currently using? Do we know we have removed? So if we have a proper audit logging, who is currently accessing my password? Who is currently fetching the database passwords, SSH keys? Using this audit logging, we can figure out who and all currently having access. So these are the main 4 features that Vault is providing us in order to achieve the better secret management for this multi-cloud environment. Cool. Now enough of theory. Let's jump and run Vault. Are you able to see my terminal?
Yeah, it's visible. Maybe you can zoom in a bit.
Sure. Cool. Now I am going to run a Vault. Currently, there is no Vault running. So I'm going to run a vault in my local. So if you see, I'm going to run a vault server with this configuration. Let's quickly see what is this configuration. So I'm telling enable the UI, run this vault in the port 8200 and store all the values that I'm giving in this path. So we can have multiple storage. We can store this credentials in the Postgres. We can store these credentials in the console. Or so if we are running the vault in the dev mode, it will keep everything in memory. So dev mode is only for playing around. It is not for production purpose. Now for simplicity, I'm storing all my data that are used by the vault in this path. So I'm using a file as a backend. Now, yeah. Now let's start our vault server. Cool. So we have started our vault server. Now let's see the status of my vault server. Cool. If we see now, vault status, we are getting, importantly, we have to see two parameters. One is initialized true or false, sealed true or false. So the vault is not yet initialized, which means vault is not yet ready to store any data. Let's say we are trying to do vault secrets list. If we see, vault is sealed. Without unsealing, we cannot do anything. So in order to unseal, we need to first initialize. Let's do initialization. Vault operator init. So if you see now, these are the configurations with which I am starting my vault. So vault operator init, print the output in the JSON format. Can you start this vault with 3 key shares, out of which 2 keys is the threshold? I'll quickly share you what that means. Let me init. Cool. Now we have initted. If you see, we have provided, can you provide 3 keys? If you see in the output, so I have wrote this output in the file. So this is the output. If you see, we have 3 unsealed keys. And also we have something called root token. Now let's see the status of vault. Now the status of vault, initialized is true, sealed is still true. We need to unseal this vault in order to access it. If you see previously also, we will also get the same error because it is sealed. Sealed means it is not ready for any actions. Now let's unseal it. So in order to unseal, we have to provide these keys. So we have to provide minimum of 2 keys. When we started, we told there will be 3 shares, out of which if 2 shares, 2 is the threshold. If 2 keys are provided, you can unseal it. Now let's unseal it. So vault operator unseal key. Now if you see the status, it is still sealed, but unseal is in progress because we have given 1 key, but it is expecting 2 keys. Out of 3 shares, it is expecting 1 more key. Now let's key another key. Cool. If we see now, initialized is true and unsealed is false, which means it is unsealed now. Now let's do secrets list. Permission denied. We have to log in order to, it is unsealed, but we don't have permission. We can use the root token that we got in order to log in. If you see now, I am taking the root token from this JSON file and set it in this environment variable, vault root token. Let's quickly see that. Cool. This is the token that is there in the file. Now let's do login. Cool. We are able to authenticate it successfully. So we logged in with root policies. Now let's do secrets list. Cool. We are able to see some data. Let's deep dive into what is secrets. Let's store some key value and see how to fetch, how to interact with vault, things like this. Now vault. Let's enable some secrets engine. I will quickly describe about what is secrets. Let's see a demo so that we will better understand how to use it. Then let's talk about details about what is secret engine. Now let's enable a secret engine in the path my secrets. So we are going to use KV store, some key value store. We are going to use version 2. So with Vault, there are 2 types of KV store, version 1 and version 2. Version 2 is the more advanced version of KV store. So let's go with KV v2. Cool. Now we have enabled the secret engine. at this path. Now let's put some value. Vault KV, put my secrets config, username Dinesh, password, custom password. Cool. We have put the data. Let's quickly retrieve the data and see what whether we have put it correctly or not. Cool. Vault KV get the path secrets less config is the store. Now we can see the username and the password. Similarly, we can quickly see what is there in the UI. So it is running in 1200. Cool. Now in order to log in, we can have different types of login method. Let's use the root token. Let's quickly copy the root token. Echo root token, copy. Cool. Now we are able to log in. If you see the secret engine, which we created with the my secrets, we are able to see. Cool. So we are able to see the config that is also we created, and the custom password and the Dinesh username, whatever we created. Cool. Now, if you want to add another secret, we can add it, the key value, all the things here. Cool. So this is how. So we have enabled the KV engine, right? Similarly, we can enable the KV, the version 2. Now instead of my secrets demo is a new path. Now if we go to terminal, vault secrets list, we can see the my secrets demo. That is a new type of path in which we are going to use KV as the type, and using that we are going to store this static credentials inside the vault. In order to fetch that, we are using the root token, because we have logged in using the root token, by which we are able to fetch the things. Cool. Yeah, we have unsealed it using the threshold, minimum threshold keys, and also we are able to store and retrieve some tokens using the root token. But if you see, anybody can access or anybody can update the keys, but I don't want that. Let's quickly update some token and see. So vault KV put. So instead of my token, my custom password, I am appending 1, 2, 3. Now let's quickly fetch and see that. Cool, it is updated. So anybody can update it who is having this root token. So let's say I am giving this token to the application, because application want. So this is the username and password for the database. If I configure this root token to my application, the application can read, update. It can do anything with the root token. It can even seal the. It can even seal the vault. So in order to tell only restricted permissions for the vault, there is something called the policies. So with root token, we can do all kind of actions in vault, but we want to give very granular permission. So within my secrets, we only have to give read capabilities for particular kind of users. Let's do that. So let's create some content like this policy. So path. So my secrets is the path that we have created for the KV store. We are giving only read capabilities. This is a policy. Now using this policy, let's create a new token. So vault token create policy. Now let's give a policy. Yes. Oh, sorry. Now, sorry. We have this policy file. We have to apply this policy file to the vault policy list. So if you see, we have only two types of policies. One is default, another is root. Let's write this new policy also. Right. So let's name it as my policy. Policy.html. Now it is uploaded. Now we can see my policy in the list of policy. Now let's read and see my policy. Cool. My secrets, anything under my secrets can have read capability if somebody is holding this policy. Now let's create a token by bounding this policy to that token. Vault token create hyphen policy, my policy. Cool. Now we have created a token with token policies, default, comma, my policies. So previously when I do vault login, I will do it again. So when we do vault login, if you see, the root token is having root policies, which means it can do all the actions. Now with this new token, it can do only my policies. I mean, whatever that are defined in the my default. With the default, we can fetch the status, whether vault is up or not, sealed or unsealed, things like that. With my policy, we can do custom fetch. Using my policy, we can do fetch from my secrets, which we defined. Now, vault login. This is the new token that we created using my policy. Now we have logged in successfully. Now let's try to get vault, get my secrets. Cool. Now we are able to get it. Now let's try to put some data and see what happens. Cool. Now, in order to write into the key value store, this login doesn't have permission denied, because in this path, for this login, we have only read-only credentials. This is policies. Using policies, we can create tokens and tell what access you can do. In this way, we can do identity-based access. Using whoever is holding this token can only do this kind of action. So in this way, we can define granular way of how much granular we can define using these paths. So if you see vault secrets list, even this it cannot do, because only root can do. Now let's log in as root. Let's do the listing. Now you see these are the different types of key value stores secrets. Now for my secrets demo also we can give permission. If we just add policy.hcl for path my secrets demo, give capabilities, read, maybe we can give list. In this way it can list all what are the things that are available inside this path, but it cannot update. So if we update this policy, whoever is whichever token holding this policy can do read in my secrets and read and list in my secrets demo. This is what policy is. Cool. Now we were talking about audit logging. Let's enable audit logging and see what are the events that are happening. This is the vault server that is running. Let me minimize it a bit. Cool. Now vault audit enable. So there are three multiple types of audit logging. We are going to enable file-based audit logging. So enable file. So file path. So do the audit logging and write into this file. Cool. Now it is enabled. Now we can do. We can see what are the things that are enabling vault audit. Cool. Now let's try to fetch some data and see. Cool. 1 second. Cool. If you see now, it is telling with the root token, with root policies, this token is trying to access this data, my secrets/config. So in this way, whenever somebody is trying to fetch some credentials, we will be able to see in the audit logging of vault. Using this, we can revoke. So each token will have some, we can revoke it. So I will quickly show you that also. So vault login. So we have logged in, right? So vault token, there is something called revoke. Cool, this token is revoked. Now if we try to log in using this token, it won't allow. Full permission denied, because the token that we got previously has been revoked by the root user, because we maybe, let's say we are trying to misuse the tokens. In that case, we can revoke the token, and vault will not allow any further queries using that revoked token. Cool. So we can have multiple audit devices. So it can be file-based, it can be syslog, it can write into the system log, or it can be some socket files. Let's say you are creating some custom application which can read data from the socket files. So we can make vault to write logs into the socket, and our custom application read it and send to the central location or some logging mechanism where we can do querying, indexing, Elasticsearch, things like that we can. Cool. Now let's talk about the next important feature in the vault, that is secret engine. Now we have played with static secrets. So we were able to put the static key, username, password. We are able to fetch it, and we are able to also fetch it. We are even able to configure who can fetch what using the policies. Now let's talk about dynamic secrets. This is where the real power of Vault comes in. So it can dynamically create secrets in lot of system. So if you see here, let's quickly talk about Postgres first. So we for a Postgres, it can do something like this. We can configure, we can enable the database secret engine, similar to how we have enabled key value secret engine. We can enable database secret engine. Once that is enabled, we can configure that secret engine. So in this case, we can tell this is the Postgres URL, this is the username and password for the Postgres URL, and we can create some roles. Roles are very similar to policies. Using those roles, what can they do? Now, our application, whichever application wants to talk to the database, can ask for the credentials. So this application can have some tokens in order to fetch some tokens. So now this will request for the credentials in order to talk to the database. Now Vault will dynamically create some username and password in this database and provide these credentials to the user. User can using those new credentials can talk to the database. So these credentials will have very minimal TTL. We can define permissions. So because let's say this is only read-only application. If this application is trying to get the credentials, give only the read-only access. Create a read-only user in this database and give the credentials for the newly created read-only user. Using these new credentials, our application can talk to the database. So as we talked previously, right? Let's say somebody want to debug it. Now you are the tech lead. Now you want to give them read-only access. Now you can, using Vault, you can ask, can you create a read-only user and give to me? So Vault will give you the username and the password, and it will be valid for 1 hour. So you can tell this username and password should be valid just for 1 hour. Now you can create those credentials and give it to your colleagues. So colleagues can use this username and password and debug it for next 1 hour. After that, these credentials will get expired. They cannot use it. So in this way, we can be very sure that we can give minimal access. We can revoke the access after some time. We know who is accessing our database currently using the audit logging. In this way, we are very secure in terms of with respect to the important things like our database. Now, similarly, you can create dynamic secrets in LDAP, in Active Directory, in AWS. In AWS, right? Let's say you want to, let's say in AWS you want to do some IAM based operations. Now you can ask Vault, can you create an IAM of using this role and give me the credentials? So Vault will talk to the AWS using the configured values in the Vault, and using Vault will create things in the AWS, and it will give the credentials to us. Using those credentials, you can log into the AWS and do the actions that are provided in the policy that are written in the Vault. So now let's quickly have a look at the example for the Postgres. Cool. Now we have to enable the secrets engine for Postgres. Let's enable it. Cool, we have enabled it. Let me close the audit logging for now. Cool. Now we have enabled the database secrets engine. Now we have to configure Vault, how to talk to the Postgres. Now let's quickly run a Postgres in a container, in a Docker container. You can run it in the VM, or you can point to the already running Postgres. Now this Postgres is also started, and it is also ready to accept the connections. Now I am port forwarding all my Postgres connections to my local host. Cool. Now, cool. Now we are going to configure Vault, telling that can you use the Postgres database plugin for this role, and can you connect to Postgres using this URL localhost 5432 Postgres SSL mode equal to disabled. Using this so here username and password is Vault user Vault pass. So we have started our Postgres with Vault user and Vault password. So because we started, so we are giving privilege for the Vault to create other roles. So Vault should have a privilege in order to create other roles. Now we are going to write this configuration inside Vault. Database is running, let it run. Cool. Cool. Now we have written the configuration in the Vault. Now we can define roles. So if somebody is asking for my DB role, create a create a role with some name with a login password, and grant only select on all database. They can only do read-only queries, and the default time to live for this token is 1 hour. Maximum the user can request for 24 hours. If they're asking more than 24 hours of the new token, it won't allow. Now let's quickly write these roles also into the vault. Cool. Now we have a configured vault to talk to Postgres. We have configured when somebody is asking for a credential for my DB role, how can you create a new role? That is also given. Now let's create a credentials. Now I'm asking Vault, can you provide me a credentials? Vault read database credentials for my DB role. Maybe my read-only DB, something like this. So using this, can you give me a credentials? If we ask, Vault has given us one username and password. Using this username and password, we can connect to the database for 1 hour. Now let's try to connect to database. Now let's get the IP address of the running Postgres. So the IP address is 172.17.0.2. Now let's exec into another container. From that container, let's try to access this Postgres. Cool. Now PSQL host. Cool. Now we can specify the user. First, we'll copy the username. Username. It is asking for password. So before that, let's quickly give the database also. Postgres. Connect. Okay, I will maximize. Hope you are able to see now. So PSQL host is the another container using the this username, which is created by the vault, and connect to the database Postgres. Cool. Now let's paste the password. We are able to do. We are able to connect to the Postgres. Now let's see what and all database are there. We have Postgres vault user, these things like that. Now because this is this user only, we started the Postgres container. Now let's try to create some database. Create a database new. Permission denied. Because we logged into this account using the user v root. This is vault root my role, my DB role, and some random numbers. Using this user only, we logged in. Now this user will have only read-only permission. This is how we created a user. We configured vault to talk to vault to create this user. Cool. Now, using this, we are able to log in. Now, if we use the vault user and vault pass, we can create database and things like that. So in this way, we can dynamically generate passwords in Postgres and give to the users for debugging, give to the applications for read-only, or give to the applications for minimalistic. They can only query from this database. They can only do updates in this table. In this granular way, we can create configure roles in the vault, and we can achieve it. So this is the dynamic secret creation in Vault. So any questions in this demo? Because this is very crucial part. If any questions, I can take now.
Like if you have any questions, please raise your hand so that we can unmute yourself so that you can talk. Or you can even post your questions in the Q&A box that is given in the chat room. Thank you.
Okay, cool. I will proceed further. Cool. So we have talked about secret engines, how we are able to dynamically create. Very similarly, right? Let's say you want to create an LDAP user in order to fit some credentials or talk to other system which is authenticate using LDAP. You can ask LDAP, you can ask Vault, can you create a user in LDAP using this role? So Vault will transparently create a role for us in the LDAP and give the username and password. Using this username and password, we can log in into the LDAP and do the actions. So no longer a static username and password is needed. Dynamically, Vault will generate the secrets for us. Using those dynamic secrets, we can do it. Vault will by default rotate it. Vault can revoke it if nobody is using it. Vault, so we can even tell this password can be used only 5 times. This password is just one time. So there are a lot of parameters with which we can tweak the each and every secrets. So one such example, right? SSH into the machine. Let's say we want to SSH into the machine. So generally what we will do, we will have a public key and we will give the public key to the our tech leads or people like that. So they will put into the authorized keys into the machine so that whenever we log in, it will be allowed. So let's say you leave the company, but still you will have the public key with you. Using those public key, you can still SSH into the machine if those machines are publicly available. If they're not connected via VPN, if it is publicly exposed, using those old public keys, SSH keys, you can log in into the machine and you can do things that you want. So which is a problem. Now, using Vault, we can have a dynamically generated SSH keys and also dynamically generated tokens for SSH. So let's say I want to SSH into this VM, which is running on the Postgres. We can ask Vault, can you create a one-time SSH token? Now we can, Vault will do one-time SSH token. Using that one-time SSH token, we can SSH into the machine. Once that is done, we'll have some Vault agent running on each and every machine, which we are trying to SSH into. It will notify to the Vault. Now, if you are trying to use the same token and try to log in, it will fail because it is already used. It will be revoked. So there are a lot of extensibility with respect to secret engine. So if you see here, Vault is providing secret engine for a lot of things, for AWS, Azure, console, for data. If you take databases itself, it will have all types of databases. We have seen demo for Postgres, right? Similarly, Vault can create users in all types of database and do things for us. For Gcloud also, so it is the key value that we have just on the version 1, version 2. So yeah, so this is with respect to secret engine. So even you can write your own secret engine. Let's talk about the next topic, which is auth method. Now, we used a root token or some other token to log in into the Vault to fetch the credentials. Similarly, our application wants to fetch the credentials in order to connect to the database. So there are a lot of users are there for Vault. So using policies, we can granularly tell who can do what. Using so policy is very similar to authorization. Who can do what? Authentication, whether the user is valid user or not. So for that, Vault is providing a lot of extension. So if you are a valid user in the AWS, you can configure Vault. If the particular user is a valid AWS user, allow them to log in. If they, let's say you are running a lot of pods in the Kubernetes. Now pods will have something called secret account, service account. Using the service account, let's say this is a pod. A pod can use a service account in order to do authentication. Now Vault will talk to the Kubernetes and see whether this is a valid service account provided by the Kubernetes cluster or not. If so, it will do successful authentication. Once that is done, using the policies that are defined, our Vault will provide the token by which they can do, they can fetch the tokens, they can update whatever they want to do. So previously we have seen secret engine, which is an extensible way for storing and fetching the dynamic secrets. This is the extension of who can do authentication by using other logins, very similar to OAuth. Whether we will trust the third party, right? Similarly, here we can verify the client identity using this identity provider. Identity provider, so very similar to service account. There are a lot of identity providers. So if you see AWS, Azure, so using GitHub personal token also, you can do authentication. So let's say we are using GitHub in our organization. Now, whoever is using GitHub using this organization, they can access this Vault and they can have the role of creating tokens.
Dinesh, excuse me.
Yes.
So we are able to see only your VS Code editor.
Oh, sorry. Are you able to see now?
Yeah, we are able to see now.
Cool.
Thank you, guys.
Cool. This is the auth method I was talking about. Sorry, I stopped. I paused the share for some time. Yeah. So now each application can do authentication with Vault. Now Vault can forward this authentication to the identity provider. Identity provider, there can be many types of identity provider. It can do a Vault LDAP. Let's say your organization is using LDAP. So whoever is having valid LDAP username and passwords can talk to the Vault and create and update roles. So we can define, we can configure LDAP. Can you go and talk to LDAP whether this user is valid user or not? And we can also define, if the user is valid user, give this policy to them. So once that is authenticated in the step 2, Vault will provide us a new token. That new token will have an attached policy. That policy can be defined by us. Cool. Now I was showing this one. So we have a lot of auth methods. So we can do authentication based on GitHub. Let's say our organization is using GitHub, which means anybody in our company will have been added to GitHub. So whoever is belong to this organization can view, can talk to Vault and can view the credentials. We can give permission at that level easily. Now for all the applications that are running in the Kubernetes, we can configure Vault if it is running in this Kubernetes cluster and if it is holding this service account, because each and every container or the pod can have some service account in the Kubernetes. So using the service account, it can validate. So we can easily do authentication for human beings using GitHub and authentication for machines, for process, for applications using the service account or environment variables using the simple username and password, or we can even provide the tokens. So for humans, we can do Okta-based login or JWT-based login. So it is very extensible. So authentication is also very extensible. Cool. Now I will show one demo for auth method using app role. So using GitHub, humans can easily do logins. Now, what about machines? What about process? Now I'll quickly show you how to. I'll quickly show how machines can do authentication based on the app role. Let's enable this new auth method. So if you remember, this is very similar to previously. Vault secrets enable database. Similarly, Vault auth enable app role. This is a new type of authentication. We are enabling it. Done, enabled. Now let's write some rules. Now we are telling create my role, and my role will have some secret ID, and the token can be used only 10 times. Token will have a TTL of 20 minutes. Maximum user can ask for 30 minutes. This is default value. This is maximum value. And the secret ID can be used only 40 times. I will show you how can we use secret ID. Now let's write this role also into the Vault. Cool. Now let's create a role. We got a role ID. Now we created a role. So let's attach a role with a secret. Now let's create a secret. Cool. Now you see, we got a role ID and we got a secret ID. Using this role ID and secret ID, we can log in into the Vault. Now, if we have configured our application or process with these two values, with the role ID and the secret ID, using this role ID and the secret ID combination, our application can log in into the Vault, authenticate into the Vault, and Vault will provide us a token. The token will have the default TTL of 20 minutes, which we have configured, and the token will have the maximum TTL. So this, so if you see, we are using the secret. This secret can be used only 40 times, and the secret ID TTL will be 10 minutes. So you can tweak all these parameters. Now let's try to log in into the Vault using this role ID and secret ID. Role underscore ID. I'll paste this. Secret ID. Cool. Now if you see, we are able to log in, and we haven't specified any policies. We can also specify policies while creating the app role. Now, as we haven't specified any policies, it is created with the default policy. Using this default policies, we have a token, Vault login, Vault secrets list. We don't have permission. By default, the default policy doesn't provide permission. Maybe we can see status. It is a minimalistic access. So initialize is true, it is not sealed. So we can see metadata, but we cannot actually see any secrets. If we want to see secrets, we have to provide policies for the app role when we are creating this role ID and secret ID. Yes, I'll quickly see if there are any questions till now. Cool. No questions. I will proceed further. Cool. Now we have talked about Vault, how to work with Vault, what are the features, secret engine, auth method. Now let's quickly talk about the architecture of Vault. So as we have seen hands-on about Vault, right? Now it is relatively better to understand the what are the inner components that powers Vault. Now storage backend. Now in our case we are using file-based storage. Even the storage backend is extensible. So we can use console, we can use Postgres, we can use the basic file-based storage. Or even if you want, you can write your own storage, and you have to just follow the interfaces, how Vault can talk to this storage backend. Once that is done, you can create your own storage backend, and you can start storing all your configuration, key values, everything in the storage backend. If you see, there is something called barrier. So everything that is stored in this storage backend is encrypted. Even if attacker is able to, so let me quickly show you the file. So we wrote everything in this storage. Let's see, auth. Inside auth, there is some path, and we have something called a role, my role. If you see, there is some key value, and it is value is encrypted. We don't know what is this. Without having the encryption key, we can never decrypt what is there in this storage. So we can confidently tell, even if our storage is compromised, if somebody is able to access our database, the database used for the Vault or the file used for Vault, they can do nothing with it, because without encryption key, they cannot decrypt the values. So this barrier is the one in which we are the values will be not in the encrypted state. Now path-based routing. Now if you see, we have seen auth slash, similarly secret slash, core slash, system slash. So basically they are doing path-based kind of routing. Whenever it goes to SYS system, it will go to the system backend. Then whenever we try to add a new secret, enable a new secret. So if we try to use the HTTP calls, right? So it is having three types of interface. One is UI, which we saw in the browser. Another one is command line, which we are seeing in the hands-on. And another thing is the HTTP. If you're having a valid root token, we can make curl request. So if you see the curl paths, it will have SYS. For secret engine, it is secret slash. For auth method, it is auth slash. So using path based, it will do the routing to different modules. So, and we will have some token storage. So for rollbacking, we need to remember what is the last time we issued. Those things like this. These are the things taken care by the core module. And also, so we have policy storage, where we can define the policies. So who can have which access, and audit broker, which will audit each and every request, every secret fetching into the audit devices. We can have multiple audit devices. It can be files, syslog, sockets, as we discussed. Now we talked about the secret sharing algorithm. Now, if you see, we used two keys in order to unseal it. So this is nothing but in order to prevent people from misusing it. So ideally, whenever we do init, we will get tokens like this. So whenever we do init, we will get cluster keys. So we initted with 3 keys, and out of which 2 is the threshold. Now in a large organization, let's say if you are giving these 3, so why they are not going with 1 key? Let's say we have just 1 key. Now if that one, the person who is having that 1 key has changed his mind, that means he is become unloyal to the company, which means he can misuse the username and whatever credentials that are stored in the vault. In order to not to happen that, we are having multiple keys, because if one person have the key, he or she can lose it. or he or she can forget it where they kept it. So things like this can happen. So so Vault has made to create multiple keys. So we can have 3 keys, out of which if 2 keys are provided, it can it can function well. So in a larger organization, this let's say we are creating 5 keys. These 5 keys will be, each key will be given to CEO or CTO, people like high authorities. Now, whenever Vault got sealed it, we can use these keys and unseal it. Now, let's say some attacker have access to this Vault. Now we get to know by seeing the audit logs. Now we have to quickly stop who can access everybody from accessing the Vault. We can quickly seal the Vault using the command. Vault operator, if you see, we can seal it. Seals the Vault server. So because we don't have a permission, Vault login root. Let me log in as a root. Password first. Let's export. No. Root. I am taking the password. So let's try to log in. So let's try to seal. Vault is sealed. Vault status. If you see, initialize is true and sealed is true. Now let's try to take some AV. Currently, Vault is sealed. Nobody can access anything, which means if we know that some attacker is able to access our Vault, and if we want to stop from misusing it, we can quickly seal it using the root token, or we can give multiple people permission. So if we see, this is the seal operation, right? It will be under system path. So we have talked about multiple paths. It will be in the system backend. Whoever is having system backend can seal it. Now, if something goes wrong, we can quickly seal the Vault so that extra credentials are not leaked to the attackers. Cool. Now we can distribute the key sets to, let's say there are 5 keys. We can distribute each key to one person, and out of which 3 keys are given, we can unseal it. Now, if we want to again unseal it, we have to provide 2 keys. I will do some scripting. Cat the cluster keys, take the last 2 keys, and do Vault operator unseal. If we see now, yeah, Vault sealed is false. When we do it first time, it is in the unseal process 1 by 2. Once we have given 2 valid keys, it will become sealed equal to false. Now we can do get secrets. Cool. Yeah, maybe you can read about this algorithm, submit secret sharing, how they are able to achieve by using minimum threshold keys. They are able to generate this master key by which they are having this encryption key. Using this encryption only, they are storing all these values in the storage backend. Yeah. So one last thing to note in this presentation, right? I want to share you the extensibility of the Vault. We can write our own custom engine, secret engine. So we have talked about key value store, Postgres, MySQL. So there are a lot of secret engines are available now. So using this secret engine, we can dynamically create secrets. We can rotate secrets. We can revoke secrets. We can we no longer have to store the secrets in the config file or environment variables. Everything is stored in the central location Vault. And using policies, we can define who can do what. Using authentication method like app role, user pass, or Kubernetes service account based authentication, LDAP based authentication, we can do. We can give access to users also. We can give access to the application process, microservices also. So this is the very powerful feature of Vault. Yeah, that is all I would like to share. Any questions, any doubts in the demo? We have 5-10 minutes. I can take those things.
Thank you, Dinesh, for your presentation. It's very informative and hands-on. So let's wait for the people to post the questions on the Q&A box.
Yeah. Cool. Then maybe if you have um, any questions, maybe you can ping me in the Twitter or something, so that if anything I can help you. I have written some small blocks over here. You can have a look at it. Thank you.
Dinesh, like I have a small question.
Yes, sir.
Shakil here. So we were storing a text passwords as a plain text, right? So like, is there some way like I can hash it or like encrypt it?
So we don't have to worry about it. Actually, Vault will take care of encrypting and storing all of your credentials. So during transmission also, as we are using TLS, the attackers cannot misuse it. So it is highly encrypted inside the vault. Inside the storage also, it is encrypted data. So if you are doing some hashing and storing it, so and if your application wants to consume your passwords, right, your application should know how to unhash it. So, but because everything is properly encrypted and stored properly in the vault, you don't need to do this overhead of hashing and unhashing.
Oh, fine. So like one basic question, this might be like silly. So like we have two fields here, username and password. Like based on our roles, like we can restrict people from what they can view and what they can write. So is it
Correct.
possible to restrict user, like they can see only username, not the password? Like, is it possible to have that level of granular permissions or like?
So the permissions can be granular at path level, not at the key value level.
Okay.
So maybe if you are putting, let me quickly, so vault kv put, now if you are putting something like this, username, name colon Dinesh. Basically, you have to split it into two fields, two paths.
Okay, fine.
Username can be one path, password can be another path. So in this way, you can provide read-only permission for this path, and only view. I mean, for very few set of people, you can give permission in this path.
Okay, fine.
Everything is controlled using the path.
Okay, fine. Thank you, Dinesh.
Okay, there is a question. Is there any TTL for the keys that are used to unseal the vault? For unsealing, and the root tokens are not having any TTL, because if we see here, using this unseal keys only, we can uh, create the actual master key, and using the master key only we can encrypt the data. If we lose the unsealed key, which means whatever data we are stored in the vault is lost. We can never get to know what and all what and all secrets are stored in the vault. So it is always better to have multiple key shares, and better to share it to different people in the organization, so that it is not misused. So always it is better to have 5-3 or 10-7. So I mean 10-7 means you need 7 people to unseal the uh, vault. Basically, whenever vault, now if you see now, vault status sealed equal to false. Let me quickly, I have stopped the vault. I'm restarting the vault. Now if you see the status, sealed equal to true. So whenever vault goes down and comes back, it will become the sealed state. Now using those keys, we have to unseal it again. So I'm unsealing it using a script again. Now sealed equal to false. So whenever vault gets restarted, you need to use those 7 keys or 3 keys or 2 keys in order to unseal it. So for this reason, we don't have any TTL for unsealed keys. Cool. Any other questions? Okay. Is it possible to send alert messages during the attack? Uh, So maybe, so if you see in the audit logging, we can have audit logging using 3 types of devices: file-based, syslog, and sockets. Maybe we can write all this audit to the some syslogs, and we can write our custom application where this application can analyze these logs. Let's say we will not call multiple times the username and password frequently. But if the attacker is getting the access right, they will try to fetch all the username and passwords. So if something goes wrong with respect to the audit logging, we can send some alert. So using the custom audit device, we can write our custom logic. But as far as I know, by default, we don't have any default way to send a mail. Any other questions? Cool.
Okay. So looks like we have answered all the questions. Before moving on to the next session, so let's take a quick break for 5 minutes and come back. Thank you, Dinesh.
Thank you.
Thank you, Dinesh. That was an excellent talk.
Dinesh, I think there's a question from Shubham.
Yeah. So can you give an example for the service provided by the cloud provider? Maybe you can text it in the chat. So I'm not sure which cloud provided security manager you are talking about. Yeah, maybe one advantage of using Vault, right? It is a multi-cloud in the sense if you are using something with respect to AWS based secret management, it can be used only for the services that are running in the AWS. So Hashicorp created this vault in order to solve this secrets not being there in the config file or in the environment variables, and also give support for multi clouds. So let's say some of our applications are running in G Cloud, some of them are running in AWS, or some of them are running in on-premises. Now all the three infra can be connected through one vault, and we can have multiple vault. A vault can also be running in the cluster mode, which means we can run one vault in the G Cloud, one vault in the AWS, one vault or one or more vault in the infra. All this vault can talk to each other and it can be in sync. So using the vault is internally using a protocol called Raft. Raft is basically a mechanism to maintain a same state across multiple servers. So basically, this is what Vault is using for. Sorry, console is also using in order to maintain the state. So maybe you can see about Raft. It is a very good paper. Using this Raft, it is able to maintain the same state across different servers. So if you are able to run multiple servers across different cloud providers and able to talk to each other, so Vault can provide us cloud agnostic secret management. Yeah. So basically, Vault is like a cloud agnostic across clouds secret management. Thanks, everyone.
Thank you, Dinesh. Okay, we'll go on a break and we'll be back in 5 minutes. Thank you.
சட்டை போட்டு வேடி எடுத்து ஒரு மாதிரி பாக்குற கிடைக்க சிரிப்பு வந்துச்சு காலில் வேடி எடுத்து பாக்குறீங்க.
Welcome back, everyone. So, upon next, we are presenting Demystifying Linear Regression by Birlla from Thoughtworks. Over to you, Birlla.
Cool. Hi, guys. Good evening. So, you people almost guessed every word except one, that is derivation. Yeah, we got it. Somebody guessed it as deviation, but it is derivation. Cool. Am I audible?
Yeah.
Yes, you're good.
Yeah, cool. So, demystifying linear regression. So, in this talk for the next 30 to 45 minutes, we are going to get you back to your schools, revise some of the concepts you learned in your schools, right? Stay tuned. So, let's start with the story, right? So, this is a scenario. I'm going to give you a scenario and I'm going to ask you to predict the results. So, I ran 5 kilometers on the first day. Then I ran 6 kilometers on the second day. And I ran 7 kilometers on the third day. So now, any guesses on how many kilometers I ran on the fourth day? If you guessed it, just give your answers on the charts. So yes, if you answered 8 kilometers, you just did linear regression. So my name is Birlla. Uh, along with me, Raja from Thoughtworks. We are working as a consultant in Thoughtworks. So just we're trying to going to keep the session interactively. So just answer whenever possible, right? So how did you guess that? So how did you guess that I ran 8 kilometers on the fourth day, right? So imagine a scenario, right? Instead of giving you a data, I just came directly to you. I told you that, hey man, or well, hey, I ran 5 kilometers on the first day. Now tell me how many kilometers I ran on the fifth day, right? Or hey, I ran 5 kilometers on Monday. Now tell me how many kilometers I ran on Friday. You have no idea, right? You will be like, what? How did I tell you, man? Are you mad, right? On contrary, if I give you a set of data like the one I gave in the above game, right? So I ran 6 on the first day, 7 on the second day, 8 on the third day, and then I throw you a question on how many kilometers I ran on the fourth day. You guessed it. You possibly guessed it, right? So when I give you the data, your brain starts analyzing the data and it predicts the pattern or a trend within it. So in this case, it predicts that I ran 1 additional kilometer every day. And with that, you guessed it, I ran 8 kilometers on the fourth day, right? Now, if I ask you how many kilometers I ran on the fifth day, you'll guess it. So since you find the relationship between these two variables, between the kilometers and the days, you'll probably guess the other uh, answers, right? So that's what linear regression is all about. So you give a certain data to it, it learns from the data, and it predicts the results on behalf of you. So now, how can we enable a machine to do this? So similar to us, and enable the machine to analyze the data, analyze the trends, and come up with certain stuff so that it can make decisions for ourselves, right? Let's see how we can enable this, how we can enable the machine to do this in the next set of slides. Let's take a classical problem. By end of this session, we'll solve this problem step by step, right? So this is your problem. You want to sell your house.
Birlla,
Yes.
Sorry to
your
interrupt.
audio, your voice is so feeble. Can you be a bit loud?
Oh, shit. Yeah, sure.
Thank you.
Cool. Am I audible now?
Much better, loud and clear.
Cool then. So we are going to take this problem, and by end of this session, right, you possibly have an answer to this problem. So this is your problem. So you want to sell your house, but you aren't sure about the price for which you can sell your house. So now, right, you want to predict the price for which you can sell your house, right? If this is your problem, you will follow various steps to predict the price, right? The first step will be data collection. You will start collecting the data, right? You will possibly go talk to your friends, talk to your neighbors, get the selling price on the nearby places or surroundings, right? And possibly you'll go to the websites, collect data, or you even talk to potential buyers and get their inputs, and you'll possibly collect all sorts of data that is possible, right? So once you collected the data, you'll start analyzing the data. You'll look for the data. You'll look for some patterns or trends to identify something that helps you, right? For example, how a 2 BHK costs in Adyar, or how a 3 BHK cost in Chennai, right? So you look for certain trends. Once you find that trend, you'll fix your requirement on that data set and see where it comes, and that's how you predict the result, and that's how you predict the price for your house, right? Let's go through each of these one by one, right? As the end of the first step, right, once you start collecting the data, your data might possibly looks like the Excel sheet or something like this, right? Of course you'll have various other parameters like the number of floors or number of rooms, right? But let's for the sake of simplicity, we'll take these two. We'll take the size as and the price, right? So even with this, even with the size and the price of the house, you'll have huge number of data, right? For example, consider a city. For a city like Chennai, you'll have possibly hundreds, thousands, and millions of houses, right? So manually, if you start going through each of these rows and start identifying the trend, it will take huge effort. It will take immense effort to go through it manually, right? So let's use the data visualization. Let's use the power of the data visualization to get something out of this, right? Let's say I'm going to plot this. I'm going to plot the size of the house versus the price of the house. This is how your plot will looks like, right? So do you see anything? Do you see a pattern? Or do you see a linear relationship between these two variables? A simple look will tell you that your price increases as your size increases, right? So bigger the size, higher the price. You can easily get this, right? So now, if I have a line that passes through these set of data points, then potentially I am done, right? So now given this, for example, the size of my house is 2,500 square feet. I can easily guess that it'll come around something around 90 lakhs, right? 85 to 90, right? So I can get the result once I have this line, right? So now how can we enable the machine to do this? Or the other way, how can we uh, how can we explain this line in which the machine can understand, right? For example, remember on the first game we played, we guessed that the rate of change. So we guessed that we ran 1 kilometer additionally on every day, right? So if this line gives you this rate of change, for example, if my house size increases from 2000 to 2500 square feet, this line increases the price, increases the change in y with respect to x, which is nothing but this size. And so now how can we enable the machine to get this line, right? So we learn many interesting stuffs in our schoolings without thinking much about that, or without knowing where to apply these concepts, right? Linear equation is one such thing. So a linear equation tells you a relationship among two variables in which one variable depends upon the other variable. And a linear equation can be represented like this. Do you people remember this equation? Possibly yes, right? Every one of us would have come across this equation. So this is the equation. This is the linear equation in which the variable y depends upon the variable x. Right? So we call x as independent variable. Since x doesn't depend anything, we call x as independent variable and y as a dependent variable, since the value of y is going to change with respect to x. So we call y as a dependent variable, and m is a slope. Since m tells you how my y is going to change with respect to x. For example, consider this line. This is a line. Imagine this is a line. If my x changes from 0 to 1, then my y is going to change from 1 to 3, right? So the slope is nothing but the rate of change in y with respect to x. So this case, for this line, the slope is 2. For every incremental unit in my x, I'm going to increment 2 units in y, which is nothing but the slope. And c is the intercept. Intercept tells you where this line is going to start. Or in simpler terms, what is the value of y when x is equal to 0. Right? For example, consider this line. When x is equal to 0, my y is equal to 1. So the intercept for this equation is 1. So if we apply this, right, if we apply the values of this line in this equation, the slope is 2, which is nothing but m. M is 2, and the intercept is 1. So you'll get the equation y is equal to 2x plus 1, which is nothing but this line. So this line is represented by this equation. So any linear equation will give you a straight line. One example is this, right? To understand it even more better, let's do it in the reverse way. So this is our equation, y is equal to 2x plus 1. Let's say we start plotting this. So when x is equal to 1, y is going to be 3. So 2 into 1 plus 1, which is going to be 3. Similarly, when x is equal to 2, y is equal to 5. So when x is equal to 3, y is equal to 7, right? So you get these points for this equation for different variables, different values of x. When you plot this, you'll get a straight line, which is nothing but the line we saw in the previous line. So now this line is nothing but this equation. So this equation will give you this line. If you see the difference of these variables, 3, 5, 7, it is 2. 1, the difference between 1 and 3, 3 and 5, 5 and 7, which is going to be 2, which is nothing but the slope. And 1 is going to be the intercept, which tells you where this line is getting started, or where your line is going to pass the x-axis, right? So any linear equation will give you a straight line. So these are the different equations that corresponds to different lines. So for example, y is equal to 20x will give you this line, y is equal to 60 will give you this line, or y is equal to 32x plus 6 will give you this line. So these are the different lines you get for different equations, right? So your machine is going to understand this line by this equation. So there are two interesting stuffs in machine learning world. One is the parametric models, and the other one is the non-parametric model. So in parametric model, we fix the number of parameters. For example, in our equation y is equal to mxc, M and C are the parameters, right? So we fix those two variables and we started predicting it. Whereas in non-parametric model, the parameters are not fixed. Even the parameters keeps growing when the complexity of your data grows. So our equation, our model, linear regression model, comes under parametric models where you fix the number of parameters you are going to use, right? So now you know the data, you have this plot, and you know the different lines, or you know the different equations that gives you this line, right? If we combine these together, you'll get this, right? This is with our data set, and these are the different equations we have, and right. So now you can clearly see now the problem shifts from one thing to other. So initially we had the data, we used the data visualization to get an idea of the data, and we know we wanted a line to predict the result, and we use the linear regression to get this line. And now the problem shifts from predicting the line to predicting the best fit line, right? So if you see these four diagrams, if I ask you which line explains my data well, or which equation explains my data well, it is going to be D, right? So D explains, this equation explains my data very well. So if I point this, if I plot this equation, or if I substitute this equation, I'll get exactly more or like the same data as I have, right? So now the problem shifts from predicting the line to predicting the best fit line. Any idea on how we are going to do that? Let's see, right? Stay tuned. Over to you, Raja.
Thanks, Birlla. Probably let's move on to the next slide as well, I guess, unless we are waiting for some answers from the chat. Cool. So as Birlla was saying in the previous slide, our problem right now lies in finding what would be the best line for our data set. We can find multiple lines. So basically, when you say multiple lines, we are trying to find multiple values of M and C, at least according to the equation which we saw earlier. So we need to identify how we can find what is the best line. For that matter, let's go back, right? What we said is we are always trying to predict what will be the value of y given the value of x. Basically, given my data set or something like given I run this much kilometers, I want to find how much I'm going to run tomorrow. So since we have the data set, can we take some of those data itself and try to predict what the equation is going to do? Say maybe like y is equal to 2x plus 3, let's try it once. Y equal to 3x plus 5, let's try once. If you keep on trying some of the values of M and C, right, you will get different predicted values. So cost function basically says, here is your prediction and here is the actual value. So the difference between these two is your cost or error. We want to predict a function which has the least error. So that's why it's called cost function. Basically, it's a cost. We want to reduce the cost. Simple economics, right? We are always want to reduce the cost. So the whole idea is find an optimal cost function so that you are bang on prediction. So there are many cost functions. Some of them is illustrated here. One is mean squared error. Another is root mean squared error. Both are for a regression problem, which we are discussing right now. Whereas the other one is cross entropy log loss, which is typically used for a classification problem. So we will specifically zoom in at one specific loss function, which is mean squared error, which we'll see in the next slide. Yeah. So as we were discussing earlier, we always try to predict, which is here the y hat I, whereas the yi is the actual value. So mean square error is very simple. It just says for all the data set available, try to predict a value and then find the difference between these two values and do a sum of that divided by the total number of samples. That's all it is. That equation says. So it's going to give you a simple mean squared error saying like, okay, this is what I predicted and this is what I had actual. I just do a difference. I get this is a simple cost function. But this simple cost function can help us to identify among a set of lines or among a set of equations, which one is the best equation. So let's delve further into this, right? you know this cost function is going to give that. So this is just a worked out sample of what we saw earlier. So for x equal to 1, the actual value is 2, but we predicted the value is 1. So the difference is 1. So it explains at various data points, and it actually shows what is the total cost. So if we predicted this line, saying this is going to be our estimated line, we have a cost of 2.34. The ideal cost in an ideal world, we would want it to be 0. But again, it's an ideal thing. Since we are dealing with probabilities and we are trying to predict, it's never going to be 0, but we want the lowest cost possible. That's pretty much our goal. Uh, please ask any questions in the Q&A section. So even if I notice, I'll probably try to answer that. So yeah, our goal, as we discussed earlier, is to find the combination of parameters M and C for which we find that the cost is minimum. So this picture looks a little bit unwieldy, but basically it's a 3D plot. That's all it is. So one side we have the M, which we want to find out. And another side we want, this is the C. So M is the slope, as Birlla was discussing earlier, and C is the intercept. We want to find a cost function which gets reduced for an optimal value of M and C. So when we try to plot the cost function as a function of M and C, we get this nice kind of little bit like a contour plot, which is bell-shaped curve. I mean, inverted bell-shaped curve. So we want to find the minimum of cost. So that would be somewhere in the middle of this particular diagram. So that particular point actually has the lowest cost function, which will give us then optimum value of slope and an intercept. So let's move on. So the question is, how do we find this particular cost minimum value of cost for a value of M and C? That's the problem we have. So can we do this manually? Yeah, we can do this manually. Try out different values of M and C. You can keep on doing that. It will be a lot of computation, and still we don't know like when is the lowest cost function. Maybe you would have thought like, okay, yeah, trying with different values. I will see, okay, this seems like a lower cost function, but bang, oh no, trying a different value of M and C can give you even lower cost function. So we'll have to actually find an appropriate way to say, I know this is the line, and how can I compute that in an optimal way rather than randomly trying out different values of M and C. That problem is actually solved by an optimization problem called gradient descent. So, I mean, pretty much we would have heard various optimization problems in our normal engineering world as well. So we would say like, okay, follow a greedy algorithm. Just try to find the local optimal thing and then try to go for the next one. Maybe like knapsack problem. So gradient descent is one such optimization algorithm, which we will delve deeper into the subsequent sections. So yeah. So ideally what the algorithm says is start with any M and C value, maybe 0, 0, because we don't know what's an ideal value of M and C. So let's take that particular point. Now find the derivative of mean square error with respect to the slope. Basically what we are trying to say is we are trying to reduce both M and C, or trying to find the ideal value of M and C. So it has to actually move from its current place so that we get a lower cost function. As we were discussing earlier, the rate of change is always given by slope or derivative. So what would be the smallest change so that we can get an ideal value in respect to slope and the intercept. So this gives us partial derivative equations. So that's pretty much is what written here. So we are trying to do a partial derivative of mean squared error with respect to slope and also with respect to intercept. So yp here means the predicted value, while y means the actual value, and x is the original data point. So taking an example of what Birlla was covering earlier, we were trying to predict house price per square feet. Here, y would be the actual house price, while x will be the square feet area, while yp will be the predicted house price. So these two actually give us the step change, or like the smallest change we need to take towards finding the optimal cost function. So if for example, if we start with 0, 0, and this equation gives d by dm as 0.1 and d by dc as 0.2, what we will do is we'll move from point 0, comma 0 to 0.1, comma minus 0.2. Basically, that is the smallest change we make. Then we recompute the cost function and compare with the previous cost function to identify whether this cost function is lesser than that or not. If it is not, we have made a we have taken a wrong step, and then we will do the partial derivative again. So this keeps on happening for a certain number of iterations. Can you move on? So yeah, this shows the gradient descent in action. So ideally here we have started with the point at since it's a 3D plot, I'm just saying m is slope is 2 and intercept is somewhere around -10. We started from there. We take the smallest step. Then next we take the smallest step. We keep on taking the smallest step. So it's always like it goes towards finding the global minima or the lowest cost function. So it keeps on taking the smallest step, and once it reaches the minimum cost function, we know that there's not going to be any other lower value than this. But even then, we cannot be actually sure this is the minimum cost function. So what we typically do is we run the algorithm for a certain number of iterations, and we see that if the step change doesn't happen for 10 to 15 or 100 iterations, we determine that this particular algorithm has reached the global minima. That's pretty much the way we find out what is the global minima in our current use cases. So as the global we reach the global minima, if you can see, we get a tight fitting line as shown in the right side of the diagram. So it slowly moves towards the points so that the line actually passes through all of these points. So this is the algorithm which we can try to use to find an optimal line fitting to our problem. So let's move on. Yeah. So we saw a problem of trying to predict the house price with single input, which is square feet rate. But largely that is not the case. A 2000 square feet area in Adayar is not same as a 2000 square feet area in Tambaram or a different place. The location of the place, location of the flat also matters. And also something like if your house has 2 bedrooms or 3 bedrooms, that is also a differentiating factor. Somebody might prefer the price might be higher for a 2 bedroom, whereas the price might be lesser for a 2 bedroom, but the price might be higher for a 3 bedroom flat. So there is always multiple variables in play, and we cannot just say go with considering only one variable as input to predict the price of an house. So multiple linear regression helps us in this particular aspect. So when there are more than one independent variable, as we discussed, multiple linear regression comes to our rescue, where we can try to find, using multiple independent variables, what is the price or what is the dependent variable value. So again, it's a prediction problem, but which just can be done with multiple independent variables. So I'd like to show a demo. Yeah, so there was a question, why we are using derivatives. Okay, cool. So when we say we want to find the smallest change we can make, because there is always we had an initial value of theta and we want to identify what would be the next smallest step which we can take. Derivatives or slope or the gradient actually gives you what is the smallest step you can take. So that's why it's even called gradient descent. We are actually moving, we are descending the cost function in values of the smallest change or the slope. And derivatives is equal to slope. It's like the step change, delta y by delta x, which is basically a small change in y for a small change in x. And that is the reason we use derivatives to find the optimal value which we have to take, or the smallest value of change which we have to make.
I'll to add on Raja. So derivatives will give you a slope. As Raja said, derivatives is nothing but the slope of a point. I mean, like the slope at a given point. For example, as we see in the three-dimensional plot, right? So we want to find the slope. We want to find whether the cost is increasing or decreasing. We want to go in the downwards pattern. We want to reach the bottom of the point and not the top of the point, right? So this slopes helps us identifying whether we want to move ahead, move in this direction or in the other direction. For example, when you take a slope at a given point, if that slope is positive, then that means that your function is increasing. So from that point, if you increase your point in x-axis, your function is going to increase, which means that your cost is going to increase. Whereas a negative slope tells you that if you going to increase your x value, your slope is decreasing, which means that your function is decreasing, which means that your cost is ultimately reducing. That is the reason we use derivatives. Yeah, over to you, Raja.
Sure, thanks, Birlla. Let's see a quick demo of the problem. So yeah. Okay, there was another question. What if the data is non-linear? Yep, there can be a lot of cases where the data is non-linear. And at that case, linear regression might not be a good fit. But even then, we use linear regression for some of the cases, because linear regression is a simple model where we can identify what feature actually affects the result. For example, in the case of house prediction itself, does location or the area or the number of bedrooms affect the most the house price? To find that, if you use a inflexible model like linear, it's not flexible enough. That's evident, right? Because if the actual data is not linear, it wouldn't be predicting it most accurately. But it can tell you which contributes most to that. We all know, like, most of the times it's like the most determining factor is area or the square feet. So it is well suited for a class of problems which we call as inference problems. And it's also one of the simplest models to implement. But there are other complex models, something like, okay, let's even take polynomial model, which can give you a better prediction in case of non-linear equations. And then there is some concepts like neural networks, which we can use to model the data set exactly, and we can get better predictions. But once we start moving in that direction, right, we lose the inference properties. I can get an accurate prediction, but I would not know which feature actually or which specific area of the data set contributed to it. If this has been an image classification problem, right, linear regression would be like failing hands down. You would definitely have to use something like convolutional neural network. But considering the data is close to linear regression might be a good choice. Yeah. So the intention is to quickly show the algorithm which we saw in code. So I'll try to go ahead. Yeah. So this is the first data set, first case, where we have the area of house in square feet and the price uh, in dollars. Actually, I couldn't get India's data set, so it's more like a data set of somewhere outside India. So it's in dollars. Yeah. So what we do is we want to kind of normalize the data so that we don't deal with such a large number, rather than using 2000 and not 4600 or something of that sort. we try to reduce the problem to a smaller size, which is like we call this standard scaling. We try to find the mean of all the data set and then try to do divide it by the standard deviation. So this is more like a normalized data set. This is plotting the data set. As Birla showed earlier, we plot the data set to identify the trend, if there's anything possible at all. And this trend mostly looks like a linear trend. So basically, as the area increases, we could see easily the price starting to increase. And if a line, if we can draw a line, I think it more or less we can model the relationship. With that confidence, what we are trying to do is we write a simple, we try to apply linear regression. And for linear regression, as we saw earlier, we need two things. One is finding the cost function, and another is trying to find an optimal way of calculating the cost function for the various values of slope and intercept. So the first step is the cost function, which we have written. So we are just trying to compute predicted value minus the actual value, that is like x into theta into t. Theta is nothing but a value of m, slope, and an intercept c. Yeah, sorry, I was looking at chat. So once we have that, we we actually find the cost of this at the value theta of 0 and 0, because we don't know what is the value of theta, that is m and c. So what we do is we initialize it to 0 and 0 and try to find a cost. So we got a cost of around 0.489. It means nothing right now. We don't know whether it's low or high. So what we have to do is we will run the actual gradient descent problem for a certain number of iterations. And what we have run here is 1000. So the question might be like, how did you come up with 1000? Actually, I didn't come up with 1000. I tried 10,000, 5,000. But how I found out 1000 as an optimal value is, this is the cost function. So the cost function drops, and after certain time, it mostly stays flat. As we discussed earlier, if the cost is staying flat at certain point, that means it's the global minima. It's no longer going to get reduced. So considering that, we finalize the number as 1000. So it was actually a little bit of iteration, but I found the right number and I just put it here. So this is also something involved as hyperparameter tuning and all those aspects to find the appropriate number, but that would be like a little bit beyond the scope of this talk. So once we have calculated the optimal values of theta, that is slope and intercept, we can plot the predicted value and the actual value. So the dots are the actual value, while the predicted value is the line. We can see the line is not like a perfect fit. It has like differences here, 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 but it more or less covers this particular range. It can give you a close enough prediction, but it's not a perfect prediction. Rarely in the world we get a perfect linear data set, so there will always be a error in our prediction.
Raja, you have a question on the chat.
Yeah, the question is, why not at 200 iterations? We could have stopped at 200 iterations. Definitely not an issue. Why 1000? Yeah, as I said, I was starting from 10,000, so 1000 seemed a good number. But the ideal case is we will have to identify at what range we reach the global minima. So 200, yes, 200 could be a value. No issues on that. So yeah, this is my rough 3D plot trying to plot the cost function. It didn't come out well. So I was experimenting a bit. So I wanted to put a surface plot, but unfortunately I was not able to do. So this actually shows the cost function getting reduced at this particular point. So this is like the lowest value of theta. So it has gone up and down and all those things, but it somehow identifies the global minima. So all said and done, Birla's original problem was he was looking for a way to sell his house, and he wanted to know what would be the price for it. That's what we started with. So after coming up with all of this, we still have the original problem of how to find what is the price of the 2000 square feet. So this is the 2000 square feet, which is Birla's house, and these fancy numbers are nothing. We initially did standard scaling, if you remember, because we didn't want to deal with huge numbers. We wanted to reduce the numbers between 0 to 1. So this actually comes from here. So here I have printed what is the mean of area, what is the mean of the price, and what is the standard deviation of area, and what is the standard deviation of the price in the original data set. So I'm just doing the inverse of this to say if 2000 is the input, just subtract the mean of the area and divide it by the standard deviation of the area. This gives me a value in the feature vector space which we were using. And then multiple questions possibly, I'll take it afterwards. Yeah. So yeah, once we get the predicted value, and then we try to multiply with the calculated value of the theta, which is what we calculated, which is what we got from the gradient descent. So once we get the gradient descent, once we get the theta value, we multiply it with the predx, which sorry for that. Yeah. So this is the area which we did. So we converted into a feature space in our data set, and then what we did is we multiplied it with theta to get the predicted value. Even the predicted value is not in the space we want, it's still in the normalized space which we had. So we had to still convert it back into the price level, which is like the $340,000 or something of that sort. So what we are trying to do here is we are multiplying with the mean of the price and then adding it with the standard, we are multiplying with the standard deviation of the price and then adding it with the mean. Basically, I'm just doing an inverse of this particular operation. That's all I'm trying to do here. So once that is done, I pretty much get what would be the value of a 2000 area square feet, which is 3,40,321, 340K, which is more or less closer to our actual data set. So, I mean, you can even see here. So 2104 is 399K, and we have predicted it to be 340K, considering we don't have the other information of bedrooms. So yeah. Now to take multiple linear regression, it's about more a number of features. So we have additional features. We just task those additional features and then follow the same approach. Run a gradient descent, compute the cost, and then plot the approach. Again, this data set falls flat around like 200 iterations or so. All of this said and done, we would get the final value for a multiple linear regression. Now, all of this is a little bit of work for us to code all of this. Like we have to find the cost, we have to find the gradient descent, and all those things. So what sklearn, scikit-learn library does is all of these abstractions have been coded optimally under one particular thing, which is called linear regression. So here we just call linear model.linear regression, and we give the x and y, and we are able to get a prediction. So those huge amount of lines which we have written have been actually abstracted into this, and we are fitting the model on this, and we are predicting it. So this work is abstracted under this particular library, and most of the times we use these libraries to actually make the prediction rather than trying to roll out our own implementation, because these implementations have been coded by various statisticians in lines with programmers, so that they are an optimal version of the algorithm which we are trying to solve. I'll stop sharing and possibly we can see the questions.
Yeah, somebody has asked about overfitting. Yes, in the example, we overfitted it with the data, but the idea of this talk is to give an idea on how to run a linear regression and not to solve the problem. That's why we did that. So, but in the real world, we won't do that. Since we are not covering overfitting and underfitting as part of this topic, we just left it as it is.
So we have 4 questions from Amir. So this has been asked in our YouTube channel, YouTube live. I'll post the questions in chat so that you guys can answer. We have 4 questions.
Why do we normalize the data set? Raja, would you want to give a try?
Yeah. So the general thing is right. There is actually a huge variance between the data. To be fair, right? This is like a simple problem where we took only one feature, but let's take multiple features, right? So one would be in the feature space of something around 5,000 or something, and one will be within the range of 1 to 10 or something of that sort. So machine ideally what we see is an higher value indicates that it's actually more prominent feature or something of that sort. The difference between those features becomes huge. So what we generally do is instead of biasing the machine with those values, we normalize them so that they fit into the same feature space of 0 to 1. Or I mean, we applied here standard scaling, but there are other scalings as well. So if you use standard scaling, we fit the data between 0 to 1. So right now, all it says is everything's within the feature space. So there's no huge value which can actually bias the model to say, okay, this is the reason this is happening or something of that sort. So that is one of the reasons that's predominantly the reason we normalize the data set. I hope I answered the question of Amar Prakash.
We have another question from Jay.
What's the optimal model used for this problem? I mean, I understand the question is like, what will be the optimal model for this problem? In that aspect, I would say for this particular toy data set, linear regression itself seems to be more or less optimal. But if you want to actually go ahead and prove that, we can go for a little bit of a polynomial model to compare the cost function, but we didn't specifically cover about the cross validation and the test data set. So basically, when we say we compare two different models, right, we would want a way to identify which model is performing best. So that's where one of the thing is mean square error, which we discussed. So we will have to compare multiple other models mean squared error. And even then, since we have only the training data set, we shouldn't just believe that the mean square error we get on the training data set is enough. So ideally what we would do is we will split the data into multiple splits, something like if it's a cross validation, we would have split it into 5 splits or 10 splits, run the algorithm on each of those splits to identify what is the error or the mean square error, and then try to compare it with other models. What is the RMSE in the current problem? The cost function we implemented is mean squared error. Square root of mean squared error would be the root mean squared error, and that is calculated via the cost function.
Any questions or we'll wind up? Is Python better?
Not specifically for this problem. That's okay. Uh, Typically, Python or R both can be used to solve much of the machine learning problems. Both have extensive libraries, but R is specifically used by. I mean, it favors a lot of statisticians. They seem to be very much comfortable, whereas Python as an ecosystem seems to be very comfortable for engineers. And one more thing is how we can scale some of these machine learning problems in distributed nature. So that if you do consider we have to scale this algorithm across multiple nodes and a distributed paradigm, Python would be an optimal choice because it has large interoperability with other distributed frameworks. R also does something in this manner, but the integration of R is not that great as Python, at least as far as I know.
Okay, I think we have covered all the questions. Thank you, Birlla and Rajagopal, for a very interactive session. And before we wrap it up, uh, I'm passing on a feedback link. Please spend a few minutes on filling up the form. Yeah, once again, thank you all for joining. We'll see you in the next Geek Night. Thank you.
Thank you.